Hello and welcome to the final video tutorial on time and work. In this video, we are going to be looking at how a problem can be solved in more than one way. Plus, we will be doing a question based on algebra so that you are not surprised by an unexpected version of problems on your test day. Now let us begin with our today's lesson. The first question says that a water pump began filling an empty swimming pool with water and ran at a constant rate till the swimming pool was full. At some time the pool was half full, and 1/3 hours later it was 5/6 full. How many hours would it take the pump to fill the empty pool completely? Now you see, this problem requires interpretation more than anything else. Firstly, we need to be familiar with time involving fractions. Secondly, we need to know how we can extract a value by knowing the part and whole, just like in this problem. And thirdly, we need to find the solution in a logical way. So 1/3 of an hour simply means 1/3 into 60. 60 is the number of minutes in an hour, and if we simplify it, we get 20. So 1/3 hours is equal to 2 hours and 20 minutes, right? Now, since we are assuming the total work to be 6 units, as can be interpreted by reading the question, therefore half full in this scenario would be 3/6 or 1/2, which means 3 parts out of a total of 6. Therefore, in 1/3 hours, the pool was 3/6 plus x is equal to 5/6. Now, x is the amount of water filled into 1/3 hours, and to simplify it, we get 1/3. So, if 1 part out of 3 total parts is filled into 1/3 hours, this means we are going to multiply 1/3 by 3 to get the total number of hours it takes to fill the empty pool completely. So solving it, we get 7 hours, which is the answer choice C, right? Okay, moving on to our next question. 2 taps can fill a cistern in 20 minutes and 30 minutes respectively. Initially, only the first tap was opened, and after X minutes, the second tap was also opened. If it took a total of 15 minutes for the cistern to be filled, what is the value of X? Now, for your convenience, I have solved this question in 2 ways. This slide is going to show you how we can solve a problem with the help of answer choices, and the slide following it is going to show us how we can solve a problem in the same problem in a standardized way. Now, to solve this question, we're going to first assume the work or the total capacity of cistern to be the LCM of the time durations of the 2 taps. So the LCM of 20 and 30 is equal to 60. Therefore, we will assume the capacity of the cistern to be 60 units. Now, the first tap will be filling the cistern at a rate of 3 units per minute, and the second tap will be filling the cistern at a rate of 2 units per minute, and their combined rate is going to be 5 units per minute. Let us now test each answer option, starting from option C, because the answers are always in ascending or descending order, which gives us a clue to go upward or downward in testing answer choices. Now, as mentioned in the question, the total time it takes for the cistern to be filled is 15 minutes. So if it takes 9 minutes for the first tap to start filling the cistern, then it is going to take the first and the second tap 6 minutes to completely fill the cistern, right? So if we take option C, which is x is equal to 9 minutes, then 15 minus x is equal to 6 minutes, and the 9 into the rate of first tap is equal to 27 units, and 6 into 5, that is the combined rate of first and second taps, is equal to 30. So 27 plus 30 is equal to 57 units, which is not the right answer. Now, this means that we have to decrease the number of minutes of x to get to the answer, because you see the combined rate is greater than the rate of the first tap. So we will move to answer choice B. So if x is 7.5, that means 15 minus x is also going to be equal to 7.5. So 7.5 into 3 to 22.5, and 7.5 into 5 is equal to 37.5 units. So 22.5 plus 37.5 is equal to 60 units. This means that our answer choice is going to be B, that is 7.5 minutes. We will now solve the same problem in a standard way, and before we begin solving this question, I'm going to read out the same problem. 2 taps can fill a cistern in 20 minutes and 30 minutes respectively. Initially, only the first tap was opened, and after X minutes, the second tap was also opened. If it took a total of 15 minutes for the cistern to be filled, what is the value of X? Our first step should be taking the LCM of 20 and 30 in order to assume the capacity of cistern. And the LCM of 20 and 30 is 60. Therefore, we will assume the capacity of cistern to be 60 units. And units could be gallons, liters, milliliters, etc., etc. Now, since the first tap is open for a total of 15 minutes with a rate of 3 gallons per minute, therefore, the first tap will fill 45 units of cistern, right? Now, the total work is equal to 60 units. Hence, B will fill 60 minus 45 is equal to 15 units, right? But we do not know in how much time. However, we do know that tap B is filling the cistern at a rate of 2 gallons per minute. Putting the values of W and R of the second tap, we get T is equal to 7.5 minutes. So, in 7.5 minutes, the second tap fills the cistern with 15 units of water, right? Now, we already know that it took a total of 15 minutes for the cistern to be filled completely. Therefore, the value of X would be total time minus the time taken by A and B together to fill the cistern, which is equal to 15 minus 7.5, which is equal to 7.5 minutes. Hence, our answer choice will be 7.5, that is option B, right? Let us see the third problem of this lesson. It says that a solution leaks out of a jar at the rate of P liters for every Q hours. If the solution costs $10 per liter, what is the cost in dollars of the amount of the solution that will leak out in R hours? Now, never be intimidated by negative statements. A solution leaking from a jar is as much of a work as a solution added to a jar. So let us consider work or W to be P liters and T, that is the time, to be equal to Q hours. Hence, the rate at which the solution leaks is equal to P over Q liters. Now, the problem is asking about the cost of the amount of solution that will leak in R hours. Therefore, we will have to multiply R's with P liters, and since we have been given per liter cost of leakage, which is $10, hence the cost of the amount of solution will be 10 PR over Q. So the correct answer choice would be D, that is 10 PR over Q. Easy question, right? The last question of this lesson says that A can do a work in 15 days and B can do the same work in 25 days. If they work on alternate days, starting with B on the first day, A on the second day, again B on the third day, and so on, in how many days the work will be completed? Now, our first step should be assuming the work to be the LCM of the number of days taken by A and B to complete a work. That is 15 and 25, which is equal to 75. So we will assume our work to be 75 units, right? Now, A can do 5 units of work per day and B can do 3 units of work per day. Therefore, working on alternate days, A and B will complete 8 units of work in 2 days. That is with an average of 4 units of work per day. Now you see, with practice you are going to automatically do the calculations. The step might confuse you first, but do not take stress. It is very easy. Time into rate is equal to the work done. So the time taken to complete 75 units of work at the rate of 4 units per day is 18.75 days. Now to make our calculations easy, let us ignore 0.75. In 18 days, A and B complete 72 units of work, right? Because 18 into 4 is equal to 72. The remaining work will be 75 minus 72, which is equal to 3 units. Now, going by the question, we will work on odd number of days, right? Starting from the first day. And A will work on even number of days. Therefore, on the 19th day, it will be B's turn to work, and B works at the rate of 3 units per day, and 3 units is what is remaining out of the total work. Therefore, the work will be complete in a total of 19 days, which is our answer choice B, right? With this, we come to the end of our video tutorials on time and work. I hope you've understood the topic very well. I just want to say one thing, and that is to practice. Practice, practice, and practice. With practice, you are going to excel on your test day. So stay positive, keep your spirits high, keep watching GRE Quant channel, and goodbye for now. Thank you.